Hello students. In a complex number, next point is properties of complex number. In a last period, we have seen that how to find out the conjugate of a complex number. Suppose that z is equals to 3 plus 4i, then the conjugate of the complex number that will be is equals to 3 minus 4i there. We have to change the sign of the imaginary part there. Then the first one property it is that the conjugate of complex number that will be is equals to complex number here. For that here I consider the complex number that z is equals to 3 plus 4i. Then the conjugate will be is equals to again that will be is equals to 3 minus 4i there. And if we take out again conjugate of that complex number, that means it will be is equals to 3 plus 4i there. That means it is equals to z there. So this verifies the result that it is the conjugate of complex number, that it is equals to complex number. Then second property it is that here if z is equals to z conjugate, then z is purely a real number. Z is purely real number there. That means suppose that Z is equals to 5, then we know that the Z conjugate will be is equals to 5 because it is only the real part and we cannot change the sign of the real part there. That means here we get that Z is equals to Z conjugate in that particular case there, and where Z will be the real number. Z, it is a purely real number. Purely real number there. Then same way, third one that it is equals to if Z conjugate is equals to minus Z there, then Z is purely imaginary number. Z is purely imaginary number there. For that again here if I consider there as a Z is equals to 3i, then the conjugate of that complex number that will be is equals to minus 3i because it is a imaginary part and we have to change the sign of imaginary part there. And therefore what we get that minus sign as it is, and in place of that 3i I can substitute as a z there. Therefore in that particular case what we get, the z conjugate is equals to z there. यहाँ पर z की वैल्यू क्या है 3i. That means it is only the imaginary part there, and that's why here I will write down z is a purely imaginary number. Z is purely imaginary number. Now next, the fourth property it is. Fourth property of the complex number is that here z plus z conjugate that will be is equals to twice the real part of the z there. So for that again here I consider that z is equals to 5 plus 4i, it is a complex number. Then we know that the z conjugate will be is equals to 5 minus 4i there. Then here if we do the addition of z plus z conjugate, that will be is equals to 5 then plus 4i then plus that it is 5 minus 4i there. That means it is equals to 5 plus 5 there, and then next plus that it is equals to 4 minus 4 it will be, and then I. So that's why it is equals to, then this will be as a 10, then next that it is equals to 0. But that 10 may be expressed as a 2 into 5 there, and then we know that 2 into 5 that means it will be 2 into the real part of the z there. So in this way that result verifies here if we do the addition of the complex number and the conjugate of the complex number, that will be is equals to twice the real part of that complex number. Same way, again the fifth property will be that if we do the subtraction, then z minus z conjugate, that will be is equals to twice the imaginary part of the z there. Same way, again here I consider there as a z minus z conjugate as this one as the same example, that it is 5 plus 4i, then next minus that it is a 5 minus 4i there. In that case what we get, the subtraction of the real part, that means it will be is equals to 5 minus 5, then next one that it is equals to here plus, then next that it is equals to 4, and then minus of minus 4 it will be is equals to, and then I. So here it is that 5 minus 5, that will be is equals to 0, and in that case here we get 4 plus 4 I there, minus minus plus, and that's why it will be is equals to 8i. But that 8i may be represented as a twice of the 4i there. That means it is equals to twice the imaginary part of the z. So in this way, again if we do the subtraction of the complex number and the conjugate of the complex number, we get that twice the imaginary part of the z there. Then next property it is that sixth here, that it is suppose z1 and z2, these are the two complex numbers, and then if we do the conjugate of that, addition of that complex number, that will be is equals to z1 conjugate plus the z2 conjugate there. That means for the addition we can separate the conjugate there. For example, now here I consider z is equals to 3 plus 4i there, and then next one z2 is equals to 1 plus 2i there. Then first of all we'll find out the value for z1 and then plus z2, that will be is equals to 3 plus 4i, then next plus that it is 1 plus 2i there. That means it is equals to that the addition of the real part 3 plus 1, then plus that it is 4 plus 2 and then I. So we get that it is equals to 4 plus that will be is equals to 6i. Now the LHS of that property, that it is equals to z1 plus z2 conjugate, that will be is equals to, we get that 4 minus 6i there. We'll denote this one as a equation 1. Then next one here I will find out the value for z1 conjugate. What will be that? 3 minus 4i. And then next z2 conjugate, that will be is equals to 1 minus 2i there. Then this again the addition of that z1 conjugate plus the z2 conjugate, it is equals to that then 3 minus 4i, then next plus that will be is equals to 1 minus 2i there. So here we get that it is equals to then first of all the addition of the real part, that will be is equals to 3 plus 1. Then next here we get that you can do like that also, plus sign is there and minus 4 minus 2 and then I there. That's why it is equals to 4. Then next plus of minus 6 I there. That means it will be is equals to here that it is a 4 minus 6 I. So here we get that the equation number 2 there. So what we get that from the equation number 1 and equation number 2 there, that it is the addition, that means z1 plus z2 conjugate, that will be is equals to z1 conjugate plus the z2 conjugate there. That it is a sixth property. Then next the seventh property, that the similar way, that will be is equals to here Z1 minus Z2 conjugate, that will be is equals to, we will get that Z1 conjugate minus the Z2 conjugate there. You can verify that property now. Similarly, just before example. Now we'll see the eighth one property. Again, that will be is equals to here. For the multiplication, you can separate the conjugate then. That is the conjugate of Z1 into Z2. That will be is equals to Z1 conjugate into Z2 conjugate there. Again, for that case, here I consider that Z1 is equals to 2 plus 3i. 2 plus 3i there, and then next here we consider that Z2 is equals to 5 plus 7i. Okay, so what will be the value for the Z1 conjugate? That will be is equals to 2 minus 3i, and then next Z2 conjugate, that will be is equals to 5 minus 7i there. Then next here we'll do the multiplication of that complex number Z1 into Z2, that will be is equals to 2 plus 3i, then next into 5 plus 7i there. So here we get that first of all it will be is equals to 2 into 7 there, then plus that it is 2 into 5, then next 2 into 7 and then I, then plus 3 into 5i, then next plus that will be is equals to 3 and then 3i, and into that will be is equals to 7i there. So we get that result, it is equals to 10, then next plus 14i there, then next plus 15i there, and then next plus that will be is equals to 7 3s are 21 and then I square. But we know that I square is equals to minus 1 there. So we'll use that value. It is equals to that 10, then next plus that it is 14i plus 15i, that will be is equals to 29i there, and again here we get that minus 21 because I square is equals to minus 1. Now that 10 and minus 21, that will be is equals to, here we get that minus 11 plus 29 and I there. Okay, so that it is the value for the Z1 into Z2. So here we consider that then the value for the Z1 into Z2 conjugate then, that will be is equals to, here we get that Z1 into Z2 conjugate minus 11 and minus 29 and I there. What we do there, that just there will be the change in a sign of the imaginary part, minus 29. So I will denote this one as a equation 1. That will be the LHS side of the property. Okay. Now next one, here we find out the Z1 conjugate into Z2 conjugate there. Here that will be the RHS. We know that it is the RHS part of that property. Now Z1 conjugate, we know that it is equals to 2 minus 3i there, and then next one Z2 conjugate, it is equals to 5 minus 7i there. So the multiplication, that will be is equals to again 2 into 5 first of all, then next here we get that minus that it is equals to 2 into 7i. Okay, then next we get that it will be is equals to minus 3 into 5 and then I, then next we get that minus 3 into minus 7, that it is equals to plus that it is 3i, and then into that will be as a 7i there. Now it is equals to that 10, 2 into 5 first of all, that will be is equals to 10, then next that it is equals to minus 14i, then next minus 15i, and then next here we get that plus 21 and then I there. So I square. So that here we get 10, that will be is equals to 10 and then minus 29 I and minus 21 there, because I square it is equals to minus 1, and therefore we get that here minus 11 and then next minus 29 and then I. That will be the equation 2 here. What is that? It is a Z1 conjugate into Z2 conjugate there. So from equation 1 and 2 what we get that will be is equals to here Z1 into Z2 conjugate, that will be is equals to Z1 conjugate into Z2 conjugate there. That it is a eighth property. Then next that the ninth property we can take out similar way, then that will be is equals to Z1 upon Z2 conjugate there, that will be is equals to Z1 conjugate upon it is a Z2 conjugate there. Now you have to verify that property.